Good morning, class. Our lesson today is over line segments. Now, today we're going to learn about the ruler postulate, the segment addition postulate, and congruence. So let's get started. First up, when we look at this figure right here, does that represent a line or a line segment? The answer is it represents a line because we see two arrows on both ends. So a line is written like this, AB, with the bar on top and two arrows, and it means line. The reason for two arrows because the lines extends infinitely in the opposite direction. It never stops, so that's why we use the arrows to indicate it goes on forever on both ends. Now, how about segment? If we write AB, which is the bar on top, it means segment. And the segment is bounded by endpoints. Now, what if you see they write like this, just AB, no arrows, no bar, okay? No AB with no symbol above. What does that represent? It means the length. It means the length of that segment, or it is the distance from one endpoint to another endpoint. So let's use the number line above to find the distance between C and D. Okay, so this is C, this is D. The location of C is -6 and the location of D is -4. They want us to find the distance from C and D, how far it takes to go from C and D, how many units, okay? So we can do that by counting. So 1, 2, okay? So the distance between C and D is 2. Now D and F, what is the difference? Not the difference, what is the distance? Okay, so here's D, and here is F. The location of D is at -4. Location of F is at +5. We do the same thing, count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the distance is 9. Now, this number line just represent a few number, but in reality, when you calculate a distance or in space, you can have a distance of a big number like 100, 1,000, like 10,000, right? The distance can be small or it can be big. What if the distance is too big and you cannot sit there and count? That is when we use the ruler postulate, and they give us a formula to calculate the distance between 2 points. So the distance between any 2 points is the absolute value of the difference between the number So what is the absolute value? Absolute value is written like this. Let's say absolute value of -9 is +9. So the absolute value of any number will give you a positive number. So absolute value of negative number will give you a positive number. Absolute value of 9 is also 9. So the reason why the distance have to be the absolute value is because the distance cannot be negative, right? You cannot say the distance from a house to school is negative 10 miles. Okay, it doesn't make any sense. So distance always have to be positive. Okay, now given 2 points A and B, then we have the distance AB equals to the absolute value. Okay, make sure distance is always positive. So absolute value of the difference between those 2 points. So will be equals to small a minus small b. Okay, and what is small a? Small a is the coordinate of a. Small a is the coordinate of a, and the small b is the coordinate of b. And coordinate is just a fancy word for location. Okay, and let me frame this formula. Okay. Now let's apply this formula to find the distance between, let's see, C and D. Okay, so instead of counting like earlier, we're going to use this formula to see, does that actually work? Okay, so let's do that. So I'm going to find the distance between C and D. So I'm going to have CD equals to what? The absolute value of C small minus D small. Okay, C is the location of the point C. Small c is the location of the point C, so location of C is -6. Minus of location of D, which is -4, minus of the -4. Okay, now minus of negative give me a positive. Okay, 2 negative give you a positive. -6 plus 4 is -2, and the absolute value of -2 is +2. So it works. Okay, it's correct. All right, let's moving on. Segment addition postulate. So this postulate tells us that if we have 3 points, point A, point B, and point C, and these 3 points are collinear, these 3 points are on the same line, and B is in between of A and C. So let me draw that to represent. So we have 3 points, right? A, B, and C, and B is in between of A and C. Okay, this is what it looks like. Then we have A, B, and this is addition, so we know the next one will be add, right? The operation will be add. AB add BC will equals to AC. And pay attention to the letter. And let me frame this. All right. Let's do one example here. So in here, oops. In here we have segment RT, where S is the point in between of R and T. We know that RS is 22. We also know RT is 34. RT is 34. The only thing we don't know is ST. So we need to find ST. So let's call ST is X, because we're looking for it, X. So based on the segment addition postulate, we can have what? RS plus what? RS plus ST, right? ST equals to RT. Now RS is 22. The ST we don't know, that is the unknown value X, and the RT is 34. Now it gives us the equation with one variable. This is really simple. We're going to solve for X. So we're going to subtract 22 on both sides. 22 minus 22 cancel out. So X equals to 34 minus 22, which is 12. And X is also ST. So we have ST equals to 12. Okay, congruence. What is congruent? If we have two segments with the same length, let's highlight our keyword, same length. Those two segments are congruent. Now, one thing you have to keep in mind, that for figures and pictures, we use the word congruent. Okay? For pictures and figures, we use the word congruent. But for numbers and values, we use the word equals. And everybody know the equal sign. For example, you cannot say 3 is congruent to 3. Okay, we never say that. We always say 3 is equal to 3. Now, take a look at this segment, not a segment, the figure here. Okay? They want us to identify all concurrent segments. Now, let's take a look here. We see AD and BC. AD is 11 centimeter. BC is also 11 centimeter. That is why AD has the same length as BC, and therefore AD is congruent to BC. Yes? So AD is congruent to BC because 11 is equals to 11. Similarly, we have AB and DC. AB is 5 centimeters. DC is also 5 centimeters. Therefore, AB has the same length as DC, and we can say AB is congruent to DC because 5 is equals to 5. 5 equals 5. All right, so that is all the notes for today. Let's work on some example. Let's do this problem right here. All right, so they give you this figure and they ask, is AB congruent to CD? Now, by our eyes, it looks kind of congruent, but we don't know it yet. That's what we have to prove. However, one thing we know for sure when we look at this figure is that the segment AD is congruent to the segment BC. Why? Because they labeled them the same. So whenever you look at a figure and you see any segments that has the same label, that means those two segments have the same length. So just like, take a look at this triangle right here. We see that XY and XZ, they have the same label here. So we know the value is the same. XY will congruent to XZ. So just look at the label and we will figure it out. So in this case, based on the label, I know that AD is congruent to BC. And since AD is congruent to BC, the value of AD will equal to BC. The value of AD is 10x minus 35. It will equal to the value of A to the value of BC, which is 4x plus 1. This step right here gives me the equation with one variable, and we're very familiar with this one already, so I'm just going to solve real fast for x. Our goal is to solve for x. Okay, so let's subtract 4x on both sides because I want my x to be on the left side. 10x minus 4x is 6x. I bring down my negative 35, bring down my equal sign, and on the right side, I only have 1. Now, I want all the numbers to be on the right side. That's why I want to get rid of the negative 35 by adding 35 on both sides. This cancel out. So on the left side, I have 6x equals to 1 plus 35 is 36. Now to solve for x, I'm going to divide both sides by 6. 6. I have x equals to 36 divided by 6 is 6. So x equal to 6. Now, I'm not done yet. I know that DC is 5x, okay, 5 times x. So DC is 5 times x, and x is 6. So 5 times 6 is 30. So DC is 30. Is 35 equals to 30? Nope. So because 35 is not equal to 30. That is why AB not congruent to DC. Okay. Let's moving on to the triangle problem. Find the value of x in the figure above. Okay, like we said earlier, based on the label, we know for sure that XY is congruent to XZ. And because of that, the value of XY, which is 3x plus 5, will be equals to the value of XZ, which is 5x minus 1. And now we solve for x. Okay, subtract 5x on both sides. 3 minus 5 is negative 2x. Bring down my plus 5. Bring down my equal sign. On the right side, I only have -1. Move the number to the right side. Okay, this is +5. I'm going to do the opposite, which is -5, -5. Cancel out. The left side, I only have -2x. Bring down my equal sign. -1 minus 5 is -6. Okay, to 5x, I'm going to divide it both sides by -2, x equals to negative with negative give me a positive. Okay, always negative and negative give me a positive. Okay, so 6 divided by 2 is 3. So my answer is x equals to 3. Now, I'm going to do the we solve. Your homework today will be the you solve. And we solve and you solve are very similar. So if I give you the answer, if I solve with you in this problem, you shouldn't have any problem doing the you solve as the homework. Okay? So because this doesn't have enough space for me, I'm going to do that in here. So number 1, find BC. Find the distance between BC. Okay, so we know that the distance formula is BC equals to the absolute value. Okay, distance or the length cannot be negative. The absolute value of B small minus C small. B small is the location of B. What is the location of B? -12. Minus location of C. What is the location of C? -5. So minus of -5. Now, minus of a negative. Again, 2 negative sides give you a positive. Okay, -12 plus 5 is -7, and the absolute value of -7 is +7. So I know that AB is 7. Okay, last one. If I have S is in between D and T, okay, let's draw that. So D here, T here, and S is in between. Just, okay, put S here. They said DS is 2x minus 8. I'm going to label that 2x minus 8. ST is 3x. And DT is 52, the longest segment. DT is 52. They want us to find DS and ST. Okay, so first off, we have to find X. We have to solve for X first. So, based on the segment addition postulate, we have DS plus ST equals to DT. Okay? DS is 2x minus 8 plus ST is 3x equals to DT. DT is 52. Now, we're going to combine like term. We cannot combine 2x with a, but we can combine 2x with 3x. So 2x plus 3x give me 5x minus 8 equals 52. X is on the left side. I want number to be on the right side. Okay, so get rid of negative 8 by add 8 on both sides. This cancel out. So the left side I have 5x equals to 52 plus 8 is 60. Let me actually move this part up here. Just moving things around. Okay. Solve for x, divided both sides by 5. X equals to 60 divided by 5 is 12. Are we done yet? Nope, we're not done yet. They're asking us to find the S, DS, and ST. Okay, I know that DS equals to 2x minus 8. So what do you think we have to do? We know x is equal to 12. How can I find DS? All I have to do is plug in x equal to 12 to x here. Okay, plug it in. So 2 times 12, x value is 12 minus 8. 2 times 12 is 24. 24 minus 8 is 16. Okay. They also want to find ST. So ST is 3x. We do the same thing. We plug in the x. So 3 times 12. 3 times 12 is 36. Okay, and now we're done. All right, so your homework today will be to use solve. I will post this into the Google form and you will submit your answer on there. All right, so that is it for today's lesson. Hopefully you can understand these postulate and the congruence. If you have any questions, I'll be back on Thursday and we will talk about our 3 lessons for the past 3 days. Okay, have a good day. Bye-bye.